Okay, 12.5, surface areas of cones. A couple pictures here. These are those cones that you find on the road, like along the highway to keep you out of a certain lane. I guess they were repurposed to make a chandelier or some kind of a light. So you could actually have one of those hanging in your room if you really wanted. Ice cream cone, that's another example of a cone. Of course, that hopefully is many of our favorites. And then this is a funky, it's actually a home, is my understanding. Yeah, they're all on top of it there. That's actually a cylinder with a cone more as this area right here. Yeah, that looks like a fort that you might build. Yeah, so that's kind of cool. All right, let's look at some other cones. Let's take a picture of, focus in here. All right, so here's a cone. Notice its base is a circle. It comes to a point like a pyramid does. It's essentially kind of the same idea as a pyramid, except it doesn't have the faces that a pyramid does. I do want to point out, we will also be referring to slant height. Slant height goes from this vertex down to the base, and it forms the slant on your pyramid, and that's going to be an important part. I want to point out here's your net. Did I say pyramid? I meant cone for this. And on here, your cone, if I were to fold this up, you can see that this is the net for a cone. Okay, not great until I tape it, but that's what you got. And if I unfold it, I have lateral area. And if I include the base, then I have surface area. So this is surface area, lateral area. I do want to point out your lateral area is actually a sector. Okay, it could be a small sector, or you can have a larger sector, and you can have even larger sectors than this. Okay, it just so happens also, and this is a side point, but if I were to roll this circle, this is a circumference here. Whatever is here has to equal the circumference. Hint, hint, when you are making your cone for your city. Now, you might be thinking, hey, lateral area, that must be the formula for a sector. The problem with that is they don't, in these problems, give us this angle, because most of the time your cones are all curled up, and there's no way to show that in the picture what that angle is, so they give us other pieces of information like the slant height, which, by the way, just happens to be the radius of this sector. Yeah, in fact, normally I kind of show you how this formula came to be. This one is way too complicated. If you really, really, really want to know, page 706, bottom left-hand corner, will give you the formula for that, or how they derive the formula. But I think for the purpose of our class, this video, we are going to skip right on to what the formula is. They have lateral area equals pi r, and then slant height. Pi r L, slant height. Do not include this in your lateral area. That's the base, so this will not be included. I'm focused on this. Once again, a very large sector. And just make sure you realize that lateral area equals pi r slant height. Surface area, once again, they use T in the book, but now we're going to include this circle here. So your surface area, I gotta pick a different color here. Surface area is equal to your lateral area plus your base, the area of your base. Lateral area is, again, pi r L, slant height, and then the area of the base is a circle, so it's going to be pi r squared. So we could just use this to figure it all out. All right, we're just going to keep moving ahead. I think we can do this in one video. Example number 1, a sugar cone has an altitude of 8 inches and a diameter of 2.5 inches. Find the lateral area of the sugar cone. Pi r L. All right, so let's find the radius. The radius is from here to here. And if the diameter is 2.5, then this has to be 1 1/4, or I'll probably put 1.25. Okay, we do also need to find the slant height. The slant height is from here to here. Now, interestingly enough, I could form a triangle out of this. Isn't this 8? This is 1 1/4. So then I can use Pythagorean theorem to find my slant height. So a squared plus b squared equals the c squared. All right, so let's figure out what that is. We got 1.25 squared plus 8 squared equals c squared. 1.25 squared plus 64, and then the square root of that, I am getting 8.0971. All right, and I'm going to take that number now, I'm going to put it into the formula. So I come down here, I've got pi, I've got a radius, and the radius refers to the circle here, this radius 1.25, and then I take it times the slant height, which is 8.0971, and when I do all that calculation, as you are as well, right, because you're giving yourself a good chance to practice, I've got a lateral area of 31.7971, which I'm going to round to the nearest tenth. I don't think it says that up above, but it's going to be 31.8, and my label will be inches squared. Okay, example 2. A hat for a child's birthday party has a conical shape with an altitude of 9 inches and a diameter of 5 inches. Find the lateral area of the birthday hat. Round to the nearest tenth. So we've got pi r L again. And once again, I need to figure out my radius. Radius will be basically in there. It'll be half of this, so 2.5. Wonderful that you can see that. So 2.5. This is also going to be 9. I just need to find my slant height. Okay, my slant height will be 2.5 squared plus 9 squared equals c squared. Kind of what I just did on the last problem. All right, and I put that all into my calculator. I am finding that the slant height is 9.3408. Okay, now I just go ahead and put it into my formula here. Coming down here, the lateral area is equal to pi radius 2.5 times the lateral area, which is, or not lateral area, sorry, L is slant height times 9.3408. So I'm taking that times 2.5 times pi, and I'm coming up with this wonderful number of 73.4, and this will be inches squared. Lateral area is inches squared. Okay, example 3. The surface area of the cone. So I'm going to have to take my lateral area plus the area of the base. In this case, my lateral area is pi RL plus the area of the base, and all of my cones, my area of my base will be pi r squared. All right, so that means I need to find a radius. Check. I need to find a slant height. Check. I need to have pi, oh wait, that's on my calculator, and then I need a radius again. And I've got everything I need, so let's work this out. Pi, radius, slant height, plus pi times the radius, squared. Now, let's just all do a double check. So make sure you can get this into your calculator however you want to work it out in steps, or if you want to do it individually. I don't know how, if you're doing it one step or not. I'm going to show you 2. Okay, so I'm figuring out this, just so you can double check, 14.0743. We've got to keep all our decimal places. And then I got a 1.4 squared times pi, and I'm getting a 6.1575. All right, if I add those two numbers together, we get a grand total of 20.23, which I'm going to round to 20.2. I'm labeling centimeters squared, and we're calling her good. All right, example 4. Once again, we have to find the surface area of the cone, round to the nearest tenth. We need, I'm going to write out the formula again. We're going to have pi r slant height plus pi r squared. Radius we've got, it's the slant height we don't have this time. And we need to figure it out. So we're going to use, oh my goodness, a squared plus b squared equals c squared. So I'm going to use 6 squared plus 7 squared, because I need this, and that's the hypotenuse, is equal to, and I'm going to put L this time. So it's equal to L, this is supposed to be a 6, by the way. So I have 36 plus 49 equals L squared. And let's see, if I do the math on that, I'm getting L to be a 9.2195. So now I come up to my formula. I've got a pi, I've got a radius, I've got a slant height of 9.2195 plus a pi plus a radius of 6, and then I'm going to square that. And once again, let's just type in your calculators. Make sure you know if you're doing this right. Pi times 6 times 9.2195, and then I'm going to write down that number. You can, if you want, put that in your parentheses in your calculator. Just be careful. Make sure you do a double check to see that you're getting it right. So 113.0973 plus this number. I don't know why I'm rewriting it again, but I am. And now calculating 0.7835. I'm getting a surface area of 286.88, which rounds to 9. Let me double check to make sure I did that correctly. And I don't have a label on here. If you want to put units squared, that will cut it and call it good. All right, that ends the lesson 12.5 for today. Only just one video. I think we could kind of cram all that information in there.